Dear students, see class 10 chapter number 11 construction. In this chapter, these are very simple problems here. Okay. See question number first. What is telling? Draw line segment of the length is this. Divided in the ratio is this. Ratio means what? Ratio means a thing is divided into two parts such that one part is 5 and the second part is 8. It means total part how much? Total part is 5 plus 8, 13. Okay, means 13. You have to this divide the thing in equal 13 parts. In 13 parts, you take the one means 5 part in one side and the 8 part in another side. Okay, in this way we have to divide it. Okay, to see how we can this divide, you draw the simple straight line. Okay, just you draw the simple straight line. After that you draw another line and you have to put the compass on this point A and draw the arcs of equal length. Okay, draw the arcs of equal length. So A1, A1, A2. First arc you put here the compass mark up here, and again you put here compass mark up here. So again same, and this same process going on till A13. Okay, now you join this last point to this last point. Okay, and now how many parts you need to take out? 5. How many? In this side 5, in this side 8. You count here till here. How many parts? 5. A5 till how many parts? 5. This now what you will do? You have joined this line. You draw a parallel line to this here. Okay, on A5 point with the help of protractor or compass, not protractor, set square. Okay, so with the help of set square we draw a parallel line on a point A5. That is our required answer. This parallel line divide this our required line into the parts 5:8 means 5:8. This is now 2.9 and this is now 4.7. Okay. Now one thing question is telling that justification. What is justification? See, the construction can be justified by the proving that. How? You see here AC upon AB equals to what? Again you see here AC, this is your AC, and AB, this is your AB. AC upon AB, what is 5.8? Okay, now again AC upon CB equals to, you can say A5 upon A5 to A13. Okay, this is representing of 8 parts. Okay, from these both parts you see the ratio are the same. If the ratio are the same, then you can say this is our justified construction. Okay, basic proportional theorem you have read it very well. This you see 5 ratio is 8. It means AC upon BC 5 is to 8. Similarly, you can say A5 upon A5 to A13 is 5 is to 8 because these are 5 equal parts, these are 8 equal parts. So this ratio and this ratio are equal. You know that these sides are parallel. That's why we can use here the proportional theorem. Okay. Now question number 2. Construct a triangle of the side 4 cm, 5 cm, 6 cm, then a triangle similar to it whose side is 2/3 of the corresponding side. One thing you notice here, fraction and the ratio both are very different. In the ratio you have to add these both parts. Okay, but when you see the fractional part is given, you don't add. Just what you see, the denominator parts representing your original value. This 3 means your original value. It means suppose your the first triangle is the side is 3, then the next triangle what is the side is 2. It means is this. Okay, now it means the first triangle is bigger and the second triangle is your smaller here. You see 3 is bigger value and 2 is smaller. Okay, so this we have to do in the triangle. Very simple. Okay, first we have to do construct it, then after we have to do justification of it. Okay, first we have to construct. First you draw the triangle construction is very simple. This is A, B, C, and these are the sides 5, 6, and this. Okay, after that you have to draw it in the ratio 2 is to 3. I have told you 3 is your original value, means 3 is your original triangle. This is your original triangle. It means this line you have to divide in 3 equal parts. It means you have to put here compass and this draw a line and you divide this line in 3 equal parts. First with the help of compass, 1 part, 2 part, 3 part, and this final point you join to this final point. Okay, after that you have to go till 2. 2 means your smaller value. It means we are coming inside. Okay, inside means you have to draw parallel line from A3 to AB on the point A2. Okay, because we have to choose here only 2 point 1, 2, because 2 by 3 means 2 part you have to choose only. 2 by 3 means you can choose only here 2 part. Okay, now from this line parallel we have draw a line, then we will get a B dash point, and the B dash point we have draw again a parallel line that is parallel to BC, because triangle must be similar. Triangle must be similar. So we have to draw a parallel line on the B dash point. Now this triangle we have got here, this triangle A, B dash, C dash is our triangle whose value is 2 by 3 of the triangle ABC. Okay, means of original triangle, this triangle is 2/3. A dash, A, B dash, C dash. Okay, now justification. See how we do its justification. The construction can be justified by proving that AB dash equals to what you see. AB dash, this is a whole part 3 and how much it is 2. Otherwise you can apply here the proportionality theorem. You can see here AB dash upon B dash B, or you can say AB 2 by 3. Okay, similarly you can say B dash C dash, B dash C dash equal to BC what 2 by 3. Okay, and AC dash equals to, you can say 2 by 3 AC. This we have to prove. How we can prove? See, construction we have done B dash C dash parallel to BC angle. You see there angle AB dash and ABC, these are equal. Why? Because these sides are parallel, so interior angle are equal. Okay, next AB dash C dash ABC, and triangle AB dash and ABC. Okay, so you see we have to write here this we have already proved, that's why we have to written here this. Next we have to say B dash A and C dash, means this talking about A, so this is a common angle, this is your common angle. Now the next A, B dash, C dash and ABC. You see if these sides are parallel, then the upper angle, these two angles are also the same. Okay, that's why we have to begin. It means from angle, these triangles are similar triangle. If these triangles are similar, it means the ratio of these triangles are same. Okay, it means AB dash upon AB, B dash, C dash upon BC, AC dash upon AC. Okay, now similarly in the second triangle we have to prove it, and after that we conclude that the ratio is 2 by 3. We can put equal to that of that triangle. Okay, in the this we have to justify our construction. Next, construct a triangle with the side this, then the another triangle is the ratio 7:5. This is a very simple problem also, and very simple. Just you have to draw a bigger triangle. Okay, first this is a smaller value, original triangle is your smaller, and the required triangle is your bigger triangle here. Okay, so this problem I can do very easily. See how you can do. Just to draw a triangle. Okay, this is your original triangle here till here. Okay, and how much you have to draw? 7:5. First you draw another line and do it 7 equal parts. 5 is original, so this a5 you have to join with original value, which means b a5. Okay, now you draw the parallel line. You have to move on the 7 parts, so you have to move in the forward direction here, and you join, you will get b dash point, and from this line parallel to this line you have to draw. Okay, now you know that this triangle and this triangle are a similar triangle. The ratios are same. Okay, if the ratios are same, it means you can say, if I say a a7 upon a5, then what you say? 7 upon 5. Okay, similarly you apply here the similarity properties, and you can prove that these triangles are similar. Then after you can prove that this ratio are the same ratio. Now this question number 4 is also very easy problem. Construct an isosceles triangle with the bases this you can construct very simply. First to draw a line. Okay, altitude is 4 centimeter. First you draw a line and bisect them. Then after you have to choose an altitude 4. After 4 chosen, you have to choose this side 8 centimeter. Then after you will get your required triangle. After that you have to do construction. What you will do there, 2 1 2 plus 1 3 by 2. It means here again you need to get a larger triangle or bigger triangle. That how you can get. Just simply you do here 2 equal parts. You do have the 3 equal parts, and 2 are your original parts. Three parts, 2 are original parts that we have to join. After that we have to move on the third part, which we have to join here. This again we will get here the similar triangle, and from this similar triangle we have to apply the same properties, and we can prove that this triangle also divided in this ratio. Again this problem is very simple problem. Here you will get a smaller triangle. Okay, so this you also do yourself. Next question number 6. Draw a triangle. This is just 4 by 3 times of the corresponding. 3 is the original, 4 is your larger value. It means it is your larger triangle. This is also very same problem. You do yourself. Question number 7. Right angle triangle. This. Okay. Construct another triangle whose side is 5 by 3 times of the corresponding given triangle and justify your construction. Very simple. This problem also you do yourself. Next 11.2. Draw a circle of radius 6 cm from a point 10 cm away from the center. Construct a pair of tangent to the circle and measure the length. Give the justification and construction. Okay. Very nice this problem. And very easy this problem also. See how you can do this problem. First you construct a circles. You have to construct a circle, and from the center you have to mark a 10 centimeter away a point. Okay, from that point what you will do, you have to bisect that line. After that bisecting that line, you have to draw the from the bisecting point a circle, and the circle which intersect the original circle, at which point you have to join the intersected point to that required point where you want to draw the tangent. Then you will get your required tangents. See how we can do this. This is your circle of whose radius is given there. What is 6 centimeter. Okay, so we have to draw a circle with whose radius is 6 centimeter. Okay, now from the center we have to mark a point P such that the distance between P and O is 10 centimeter. Okay, now this PU we have to bisect with the help of compass. How we can bisect? You have to fill the distance in your compass more than half. How much? More than half. After that you have to do mark a arc above side from the point P and one arc in below side. Similarly, from the point O, you have to mark without changing the distance of compass. You mark arc one above side and one in below side. After that, you have to get the intersection point at M. This M is your middle point of P and O, means midpoint. From M point, we have to construct a circle. This circle intersect our original circle at point O and R, Q and R. Okay. Now this is our P point, which is having the distance from this center is 10 centimeters. Now you join the P and O and P and R. This is your required tangents. These are required your tangents. Okay, which are having the this point P, which is away from the center, is 10 centimeter. Now justification, how you can do the justification is, first you see the construction can be justified by the proving that PQ and PR are the tangent. These we have to prove that these are the tangent to the circle with center O and the radius 6 cm. For this join OQ and OR. OQ and OR. You have to join this. After joining this, what you will notice here, this angle is 90 and this angle is 90 here. Okay, see, joined here. This angle 90, this angle 90. It means PQO. PQO is an angle the semicircle. Is an angle of the semicircle. We know that the angle is of the semicircle is a right angle. So you see here in this circle, this angle must be 90, because in a triangle, in a circle, if any triangle made on diameter, then that makes a right angle triangle. Okay, so this is the diameter of this circle. If it is a diameter, then this angle must be 90. It means this is right angle. If this is right angle, it means PQ must be tangent, because the tangent always makes a right angle with its radius of circle. Okay, that's why you can say PQ is perpendicular to OQ. If PQ is perpendicular to OQ, then we can say OQ is the radius of the circle and PQ has to tangent of the circle. Similarly, we can prove for this. Okay, very easy this problem. Now question number 2. Construct a tangent to a circle of radius 4 cm point of 4 cm from a point of concentric circle of the radius 6 cm. Measure its length. tangent to a circle of radius 4 centimeter. Okay. On the concentric circle of the radius 6 centimeter and measure its length. Also verify the measurement of actual calculation. Okay, first you draw the circle here. Draw a circle 4 centimeter and a 6 centimeter. These are the concentric circle. First to 4 centimeter and this next is 6 centimeter. From this circle, on this circle we have to draw a tangent. Okay, how we can draw the tangent? See here. Construct a tangent to a circle of radius 4 cm from a point on a concentric circle of radius 6 cm. Means a point which lie on this circle and you construct a tangent on this circle. Okay, it means our exterior point lie on this circle and we have to construct the tangent on this circle. This we have to do here. Okay, see now how you can do. You have to choose the suppose this point and from this center you have to join this. After that you bisect this line, you will get here M point, and after M point you have to draw a circle and this circle intersect this circle at the point Q and R. You join the Q and R, you will get your required tangent. After that you have to give its what justification. See justification how we can do. And before that what we need to find here, measure its length. Okay, length, very simple problem. Length, you see this length how much? 4. This length is 6. 6 square minus 4 square, what is 3 2 6 6 are 36 minus 4 4 is 16. 36 minus 16 you will get 20. 20 you will get 2 root 5. 2 root 5 is 4.47 like that. Okay, this is your now the justification very simple. This again the same like that. You have to draw these lines. You know that now this triangle is right angle triangle, if this triangle is right angle triangle, then this angle is 90 degree, and if this angle is 90 degree, then you can say this is perpendicular to this, and when you say this perpendicular to this, it means this is tangent. Okay, this we have to do here. Next question number 19. Not 19, 3. Now you see the next question, question number 3. And in this question, what this question is telling that draw a circle of radius 3 cm. Take 2 points P and Q on one of its extended diameter, each at distance 7 cm from its centimeter. Okay, draw tangents to the circle from these 2 points P and Q. Give the justification of the construction. Okay, see how you can do. Just you draw the circle and you have to extend this diameter. Okay, and till where the point of you have to do 2 point P and Q. One of its extended diameter is 7 centimeter from its center. Okay. So you see here PQ is extending the both side and locate the 2 point on this diameter such that OR and OS 7 centimeter. See how OR and OS. This OR and OS. This is your PQ diameter, and you have extended in this side. You have to 7 centimeter. This is OR. This is OS. Now very simple. This you have to bisect this and draw the two circles. Then after that you will get these two tangents. Okay. Now we have to give it justification. For its justification, you join this line. This line very simple. Now its justification is also. Okay, so very simple you can say these are the perpendicular and this are tangent. Now question number 4. Draw a pair of tangent to the circle of radius 5 centimeter, which are inclined to each other at an angle of 60 degrees. Just wait a while, my dear. Hello. Question number 4 now. See this question number 4. Draw a pair of tangent to a circle of radius 5 centimeter, okay, which are inclined to each other at an angle of 60 degrees. Okay, see this how we can do. Inclined at 60 degree. Just you draw first circle of radius 5 centimeter. Okay. Now you see here, if this you want to get here 60 degree, so how you can get this 60 degree? You know that this angle plus this angle, what is 180. If this 60, then this must be 120. So for this 60, if you want to get, so you have to make here 120 degree angle. Okay. So 120 degree you have to make first angle here. Then after you construct the two perpendicular, because the perpendicular distance on the radius perpendicular side on a radius is your tangent. Okay, so this tangent and this tangent we have drawn. Now you will get here the 60 degree angle inclined it between these two radius. Okay, now you do its justification. Justification is very simple. You know that APB is 60 degree and QAB this 120 degree. If you add this, you will get 60 degree, and this is very simple problem. Now you can understand this. Question 5. Draw a line segment AB of the length is 8 centimeter. Okay, taking A as a center, and draw a circle of radius 4 centimeter, and taking B as a center, draw another circle of radius 3 centimeter. Construct a tangent to each circle from the center of the other circle. Center of the other circle. Give the justification of your answer. Okay. This is a little bit complex, but not much complex. See, you have to draw here two circles. Okay, and after that what you have to do here, draw a circle of radius 4 centimeter and this 3 centimeter. Construct a tangent each circle from the center of the other circle. Okay, give the justification of your construction. See what you will do here. You have to do first, draw this circle and this circle whose radius are 3 centimeter and 4 centimeter. I think what is this 4 and 3. Okay, now after that what you will do, each circle from the center. Okay, Suppose if you want to draw from here on this circle a tangent, how you can draw? You bisect this line. So that's why we have done means bisect this line. Similarly, if I want to draw on this circle a tangent, so we have to bisect this distance. It means in the both cases we have to bisect only the AV distance. So we have to do this just in a one figure and only one time. So we have to bisect the AV length and now draw a circle. Now this point intersection, this point and this point intersection, you join to this and this. So this PB and PQ are the tangent for this circle, okay, and AS and AR are the tangent for this circle, okay. Now after that, wait a while little bit. Oh shit. Okay. Now see, justification for justification just simple. You have to join that and you prove that they are 90 90 90 like that. Okay. Now question number 6. Let ABC is a right angle, be a right triangle. Okay. ABC be a right triangle. In this BD is perpendicular from B on C. The circle through BCD is drawn. Construct the tangent from A to the circle. Construct the tangent from A to the circle. Give the justification of the construction. Okay, construct the tangent from A to the circle. Circle where we have drawn ABC right angle, and this BD is a perpendicular from B on C, and the circle through BCD is drawn. Okay, BCD means we have to draw here circumscribed circle. Okay, circumscribed circle, how we can draw? Just we have to do angle bisector here. Okay. A, B, C. Okay, D point is it comes where BD is the perpendicular from B on C. Okay. So this is your D. Now you have to draw here circumscribed circle. How you can draw circumscribed circle? You draw on, you means it's this is your for this triangle. What is this is hypotenuse. For hypotenuse, midpoint is works as a circumcenter. Okay, so you have draw this circle. Now after that, what you have to do? Construct a tangent from A to this circle. Okay, A point is where this. From this point we have to draw the tangent. Means this point you have to join this. Okay. Now after that you have to bisect them and you join them. Then you will get your these tangents. Okay. And for justification, just simple. You have to join this and this. Whenever you join this and this, what you will notice here, this is a right angle triangle. If this is a right angle triangle, then this angle is 90, this angle 90. You say these are and tangents. Okay. Now question number 7. Question number 7, how you can do? Draw a circle with help of angle. Okay, angle you means like chudi. Okay. Take a point outside the circle. Construct a pair of tangent from this point of the circle, from this point to the circle. the justification of the construction. So whenever you draw the circle with the help of angle, you don't know where is the center of the circle. This is a problem for you. Okay. So what you will do, you draw, there are two chords in that circle and you bisect them. Okay, so this we have to do here. See, this is our circle, we have drawn here the two chords and bisect them, then we will get our center of this. Now this problem is very simple. We have take choose any point outside and join this to the center. After that we can draw any two lines that are tangent on this circle. Okay, so this problem you have to think that how you can get the center. So that's why we have to draw these two chords. This is only a mind of observation. Thank you class, and I hope this is your finished. Okay. So have a nice day, and this way I am teaching here because you can revise your chapter very easily. Okay, in a quick time. Thank you.